Welcome to ClickMyProject.com. Let me discuss about the process enabling always-on service discovery, Wi-Fi neighbor awareness networking. Let me discuss about the abstract of the project. Genetic algorithm is an intelligent optimization algorithm inspired by flocking behavior of birds. Has been shown to perform well and widely used to solve the continuous problem. But the traditional GA, most of its variants are developed for optimization problems in continuous space, which are not able to solve binary computational optimization problem. Genetic algorithm is a population-based stochastic approach for solving continuous and discrete optimization problem. In genetic algorithm, simple software agents called genes move in the search space of an optimization problem. The position of a particle represents a candidate solution to the optimization problem at hand. Each particle searches for better position in the search space by changing its velocity according to the rules originally inspired by behavioral models of genes. Genetic algorithm belongs to the class of gene intelligent techniques that are used to solve optimization problem. This system proposes enhanced OERP that eliminates an individual node formation and improves the overall network lifetime when compared with the existing protocols. Here, FP growth tree algorithm are enabled in order to finding the energy efficient shortest path, and the genetic algorithm is used to find the shortest path, whereas FP growth tree used for finding the energy efficient shortest path. Let me discuss about the flow diagram for our process. Initially, the node deployment has been proposed. Once the nodes are deployed in the sensing region, the base station broadcasts a message called info collection request message to all other sensor nodes in the network to collect the nodes information. The value of position, velocity and energy are maintained and updated at the base station. Then the base station makes the sensor nodes to perform shortest pathing. Shortest path formation performed using genetic algorithm. Shortest path formation. Genetic algorithm used for shortest path formation. There are three shortest paths in the network. Shortest pathing taking place by considering node with maximum fitness value. In the constructed network, there exists an individual node with fitness value. Such individual nodes is considered as a shortest path. In the next iteration, the shortest path is formed. The same process is repeated until no or least number of individual nodes remains in the network. The iteration with no individual node or less number of individual nodes is considered as a final best path. After that, energy efficient path has been performed using FP growth tree. FP growth is one which performs routing tree construction and finding the energy efficient path, and then that links all the nodes to all other nodes in the network. Collaborator is generally a node which detects the event and gathers information. The collected information will be transferred to the coordinator node. After the election, it becomes coordinator node. This node performs data aggregation operation and sends the aggregated to the sync node. The nodes which are in between the coordinator node and sync node are called relay nodes, as these nodes are used to forward the sensed data to the sync node. It is to be relay node. Finally, the performance graph has been analyzed. It compares the parameters total energy consumption and packet delivery ratio. The network lifetime can be improved by avoiding the sensor node to transmit raw data. The number of access packets, sensing time and also optimized energy has been analyzed. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder, exit the file and run for executing this process. Select any node among 50 nodes. Totally we have 50 nodes as a service requester, and again select service requester and select one more service requester. Select the service requester. Once the service requested got selected, we have to enter the services from remaining 45 services. Number of services 1. From choose request among A, B, C, D, E. Among these services, you have to select any one services. This is the path defined based on the genetic algorithm. And for second service requester, we have to select any one services. This is the path for second service requester. And we have to enter any one services for third service requester, and this is the path for third service requesters. And perform services for fourth service requester, and this is the fourth service requester path generation using genetic algorithm. And here the fifth service request generator has been generated, and now the FP growth path will be performed. This is the energy efficient path. After performing the FP growth, we obtain the results of the energy efficient path, and then we have to calculate the graph, that is performance analysis graph for our put results. This is the displaying process for our genetic algorithm. View paths. There are totally 5 service requesters has been provided. Select any one service requester and view request. Select any one request provided among 1 requesters. So here you have to enter 1 request and then display the paths. This is the path. Here we have select B services, and for B services we have generated 8 paths, and this is the FP growth displaying window. Here you have to select any one service requester. Here I am selecting second service requester and display the best path. This is the best path we have obtained. This is the best path location we have obtained. After that we got the graph. This is the response time graph for our existing and our proposed work. Proposed work is genetic algorithm, FP growth combined algorithm, and this is our successful completed session for our existing and our proposed work, and this is our number of control packet per session for our existing and our proposed work. Here we analyze the best shortest path and also energy efficient path using the efficient algorithm. Thank you.